So welcome to the next session, friends. So now let us discuss some properties related to Jn of x. So the first one is we have to prove that show that j of minus n of x is equal to minus 1 to the power of n into jn of x. So we have to show this. So to do this, first we need jn of x, then we can replace n by minus n. So you know what is jn of x? Summation r varies from 0 to infinity minus 1 to the power of r into x by 2 to the power of n plus 2r 1 divided by gamma of n plus r plus 1 into r factorial. Now what we do? We replace n by minus n. J of minus n of x. What do you get? Summation r varies from 0 to infinity minus 1 to the power of r x by 2 into minus n plus 2r 1 divided by gamma of minus n plus r plus 1 into r factorial. So friends, because the summation is for r, I will rearrange this term in terms of r, because summation is for r term. So I will rearrange this gamma function in such a way that it is in terms of r. So j of minus n of x is equal to summation r varies from 0 to infinity minus 1 to the power of r x by 2 minus n plus 2r into 1 divided by gamma of r minus of n minus 1 into r factorial. R minus of n minus 1. Now if you just observe this function separately, see, once again while proving I will write back this term only just to show you I have just converted. So you know this r minus of n minus 1. So because r varies from 0 to infinity, if I give the value r starting from 0 to till n minus 1, you get all negative values. I mean, till the value 0, 1, 2, 3, whatever you give, it is negative of that. So you get gamma of minus. Suppose if I just take this term as k, it is always gamma of minus k, negative number. And if you put n minus 1 till n minus 1, it becomes gamma of 0. So till n minus 1, this result is negative, which we don't want in the summation. So we just remove that result and we define this r after n minus 1, that is n. So this you have to remember carefully. So till n minus 1, this result is 0, and also before n minus 1 it is negative. So we want summation from 0 to infinity. Okay, we don't want negative terms, so we just neglect that term just for the sake of proving the result, and we take starting from n, because after n minus 1 you have n. I will take the summation starting from n, and I will write back the result in this form only just to prove the result. So what we get is, I will just write the result. So if you just see this summation, friends, so j minus n of x is equal to summation, I told you I will define r from n to infinity minus 1 to the power of r x by 2 minus n plus 2r 1 divided by gamma of minus n plus r plus 1 into r factorial. I told you why I am defining from n, because till n minus 1 it is 0, before n minus 1 it is negative. I want positive, so I will start from n. So now I defined this from n. So I will do some simplification to prove the result. So I will call this r minus n this r minus n as some other variable, say s. So if r minus n becomes s, then what is r? I'm converting r to some other variable s to prove the result. You have to follow this procedure. You have to remember this. So it is n plus s. So in the place of r, you can it is n plus s. So I can just take the limits for this. So if r is n, s is 0. If r becomes n, lower limit, n minus n, s becomes 0. If r becomes infinity, s is infinity. So what happens to j of minus n of x? It is s varies from 0 to infinity, minus 1 to the power of n plus s into x by 2 to the power of x by 2 to the power of minus n plus, see here r is n plus s. What is 2r? If I multiply 2, 2n plus 2s. 2n plus 2s into 1 divided by gamma of minus n plus r plus 1. So 1 divided by gamma of, so I will write this term as minus n plus r plus 1, right? So here r minus n, in the place of r minus n I can put s plus 1, because r minus n is s, r minus n is s, into what is r? N plus s factorial outside the gamma function. Now if you just rearrange this, minus 1 whole to the power of n into minus 1 whole to the power of s, x by 2 into x by 2 into so here if you just observe 2n minus n is n, so it is n plus 2s, 1 divided by, so I told you the property of gamma function. So gamma of s plus 1, this denominator can be written as gamma of s plus 1 can be written as s factorial, and this n plus s factorial can be written as gamma of n plus s plus 1. So in this way, if I substitute here, in the place of gamma of s plus 1 I can write s factorial, in the place of n plus s factorial I can write gamma of n plus s plus 1 into, in this place I can write s factorial. So if you just observe this, except this, so minus 1 whole power n is nothing to do with the summation, minus 1 whole to the power of n, sorry, minus 1 whole power s, x by 2, n plus 2s, 1 divided by gamma of s plus 1 into s factorial. So if you just observe this result, I will write it once again. S varies from 0 to infinity, minus 1 whole to the power of s, x by 2 into n plus 2s, 1 divided by gamma of n plus s plus 1 into s factorial. If you just observe this term, this is nothing but jn of x. So this is nothing but jn of x. Therefore, I can write j of minus n of x is equal to jn of x. So like this, we just follow the same procedure. So you can just rewind and pause the video wherever you didn't understood. So you can just follow this first property. So in the next session, I just go with another property related to jn of x. Thank you.